Ersa icon Vario 4. Let's switch it on. This is the latest firmware from 2020 and now 2023, and it's still the same old firmware, and it is a problem. I will tell you why later. It's supposed to be a fancy all-in-one made in German station with all tools available: the gun, tweezers, iron, hot air, and finally the most demanded, at least for us, pick and place pen. Unfortunately, it has failed. We still use this Chinese pump. I will explain you why later. But first let's focus on the hot air tool, and I will show you how quick you can fix small components, particularly this one, with this tool. Select the biggest nozzle that comes with this tool, this one. You set the temperature to 500 degrees Celsius. Yes, that's high. That is the trick. It will do the job. And believe me or not, I never damaged any component by this high temperature. And now let's go. No scripts, one chance, all real time. I'm just switching on this tool and start heating this place. No flux. Yeah. So I'm heating, and you can see how long it will take time. While I am heating, I am pushing this slightly to understand if it is already disconnected or not. The problem with this prototype that the footprint has been done wrong, and so we need to rotate this IC to 180 degrees. Sometimes I need to change the angle of the nozzle so that the air is coming to the right place. I don't use any preheating, and you probably notice on the video, I'm not sure because I am under the microscope, so that all plastic around is melting, but I don't care about it because it is prototype. So okay, we are disconnected this. So I'm still keep the air tool on the same place while I'm rotating this IC. I again don't use any new flux here, and I just put it again here. And now the trick is that if you heat it enough, this place, it will be on the place by itself, I can say. Yeah. Now it's not heated enough. Yeah. Okay, so sorry, I'm not sure if you will notice this on the video, but now when the place is heated enough, I can just slightly push it in different direction, and it's a kind of feedback from the IC. It will return on the same place where, not on the same, but on the place where it should be. This is the property of the solder. Yeah. So it wasn't quick because I'm trying to do the video. Yeah, but otherwise it could take just half minute to do this job. Well, actually we're already fine. That's all. Yeah. And everything is clean around because I don't use extra flux. It's fine. And what about the heating stress on the component? It's also fine. I never damaged any component by... Let's try another one. You can see how difficult it is going to be. I can remove these jumpers, but I cannot remove these two test points, the blue and the green one. Let's try. I decided to hit from this side, so switching on the tool. So I decided to hit from this side to touch less plastic on the way. So I will try. No, it's going to touch a lot of plastic around. You should figure out the airflow correctly. No, it's not the best position for the tool. Okay, let's try. Let's try from here. But I decided to change the nozzle for the smaller one, because I realized otherwise I will damage a lot of plastic around. And you can hear the air from this nozzle because it is now smaller, but at least it fits the dimension of the IC, and you can see how quickly we demounted it, and I lost it somewhere. So now I found my IC, I rotated it 180 degrees, and I'm going to place this here. You actually need to adjust the airflow to make it smaller with the smaller nozzle, but I will try with this one carefully. No, it sounds very... No. Okay, 2 liters per minute. We can... It's still blowing. Too much. Okay, but this is the minimum we can get. Yeah, so then what we are going to do, we just rotate it to the right place, and we push. That's okay, something like that, and we push it because we want first to get solder melt, and then it will not blow out the IC. But we can see, and we will see another magic in that case. Yep. Now 2 liters per minute, the minimum airflow. It's not blowing, but unfortunately it's not heating enough anymore. Yes, it's always a compromise. We are a little bit of luck for the airflow. So we ended up with airflow 3.5 liters. So we ended up with 3.5 liters per minute finally. Then I was able to fix it quickly, and you can see how nice it is because I don't use flux. I don't want to bother with cleaning and dirty around. And you can see the plastic is fine. These 2 test points are fine because of this nozzle selection. So you can use this one. You should reduce the airflow And we found that 3.5 liters per minute was good for this, yeah. Okay, we have another problem here after reflow. You can see it over there, and I will show you how we fix it. I decided to remove the whole IC because I'm afraid the problem could be beneath as well. That's why I use again the biggest nozzle, and I think I need to increase airflow. Let's try to put it 5 liters per minute we have now, and 500 degrees Celsius. That's the temperature. All plastic is melting around, yeah. So we have really hot air, but this should allow us to remove it quickly when we find the right position for the air. It might be tricky. It takes quite long this time. It shouldn't be usually that long. One of the trickiest part is to find the right direction for the air. It sometimes looks like you should blow directly to the IC, but in fact it might be on some distance or on the very interesting angle to the IC. Now we have 6 liters per minute. 500 Celsius. I can see components behind this IC are moving. Not moving, but the solder is moving. Melting. But not here. Okay. Okay, now we take it out. Yeah. So, put it here. Okay, airflow 6 doesn't blow this. That's good point. Now I just fix it like removing this jumper, and I want to make sure that beneath my IC everything is fine, so I need to rotate and look this under the microscope. That's also tricky. Okay, that's fine. Yeah, and now I blow there and there. Yep. Probably now I can show you the trick that I mentioned before. I place it without much care that it's yeah. I think I should use 7 liters per minute. Then I will show you this trick that I wanted to show you. But for now, we are ended with this one. That should be fine. Yeah. So there is another one to fix. I will increase airflow to 7 liters per minute, and probably I will be able to show you this trick. This place around unfortunately is full of plastic. So 7 liters per minute, 500 degrees Celsius. I keep the tool prepared, so it was hot when I began. Yeah, I'm blowing somewhere here. And I need the higher airflow when I'm blowing from that distance. Okay, so I put it here. I remove this jumper. Okay, I don't want to remove this component. Hey guys, okay, let's get it back later. You probably notice it's melting there. That's bad thing. Now I think I can still not show you that trick, but no tricks. Okay, that looks nice. Probably not straight, but that should be okay. And the damage is here, but that's fine to me for the prototype. So guys, let's recap. 500 degrees Celsius. Yes, 500 degrees Celsius. That will do the job, otherwise it's not. 7.0 liter per minute, you can see it here, for this biggest nozzle. Then you are good to go. And if you don't have plastic around, then you are absolutely fine. The biggest problem I have always is that it will melt plastic and I should care about it. Just briefly, why we cannot use this one. Because the program will suspend the pump if you don't use this tool for several seconds. And it is not how it works in the real life. In real life, you want the pump run like Forrest Gump all the time, and just close this hole to pick up the component, release the component, and sometimes you want to put it aside when you open the new components. You need the pump run continuously without suspending, because when it is suspended, you should go again here and do a few manipulations to turn it on again, and that is the problem. So we really can't use this fancy made in German machine, and we still use this Chinese one. Close, open, close, open. Just switch it on and pump runs continuously. Close, open, close, open. When you don't need, you can switch it off. If not the plastic round, then the job can be done for less than a minute. That's all, guys. Like if you like, dislike if you disliked. But peace for all of you.